So today I have been asked to find the magnitude of the torque about a pivot point P if a 50 Newton force is applied to it. So over here I have an image which explains the problem that I've been asked to solve for you today. So here we have the length of the wrench, which is radius equal to 40 centimeters. The pivot point P is down here, which is actually where the wrench is attached to the bolt. And then we have another vector here, which is the force applied, which is 50 newtons. And then we also have a degree angle, which is actually the degree at which the wrench is pivoting the bolt into the wall. So I'm going to redraw this. So I have one vector here, which is my radius, which is 40 centimeters, and then another vector, which is my force, which is 50 newtons, and then this angle at the bottom, which is the 30 degrees. Now, 30 degrees is not actually the angle that I'm going to use moving forward. I still have to actually find the angle between the two actual vectors that I'm using. So I'm going to switch pens. So the angle that I'm going to be using, because we need to use the right triangle, the total needs to be equal to 90 degrees, so this is going to be 60 degrees. So to find the magnitude of the torque, we first have to understand that what we're doing here is we would be crossing R times F, which is my radius times my force. And that would normally look like but I've been asked to actually find the magnitudes. What I'm going to do is I'm going to take the magnitude of both sides. And what's nice is when we take the magnitude and we're crossing these two items, to find the torque, we can actually multiply the magnitude of the radius and the magnitude of the force times sine of the angle that we found. And so that will end up looking like so as you see here, I've plugged in my values. So this is my R, this is my F, and this is my sine of theta. And I'm multiplying them all together. So doing the mathematical equation, I get 20 times the sine of 60 degrees is root 3 over 2. And I get an answer of 10 root 3 Newton meters. And there you go.